Assalamualaikum warahmatullahi wabarakatuh. In this video, I will proceed with the discussion on the exercise of 2.6121 function and their inverse. Let's look at to the exercise 1. Given the function f(x) is equals to 1 minus square root of 2x minus 5, find the inverse function f inverse x. Part B, sketch the graph of f and f inverse on the same axis. And part C, we need to find out the domain and the range of the f inverse. Okay, first let's look at to the finding the inverse function for the 1 minus square root of 2x minus 5. So how to get the inverse function? So given fx is equals to 1 minus square root of 2x minus 5. So let us put that fx is equals to y. Therefore, y is equals to 1 minus square root of 2x minus 5. And we have to put x as a subject in order to get the inverse function. So square root of 2x minus 5 is equal to 1 minus y. Then 2x minus 5, and we square both sides. So in order to remove the square root, so we will get on the right hand side is equals to 1 minus y squared, and 2x is equals to 1 minus y squared plus 5. Then x equals to 1 minus y squared plus 5, the whole thing divided by 2. Therefore, the inverse function of f is equals to 1 minus x squared plus 5 over 2. So this is the inverse function of f. Then we have to sketch the function of f and f inverse on the same axis. Okay, so it is more easier. As you can see here, the function of f inverse is actually the quadratic function. Normally, when we get the question on the quadratic function, let's say fx is equals to ax squared plus bx plus c, in order for you to sketch the graph of transformation or the graph of the inverse function for any quadratic function, we need to transform this general form of quadratic function in the form of completing the square. So in order for you to get in this form, we have to apply completing the square so that we can see clearly what is the transformation technique involved here. Okay, so let's proceed with the sketch the graph of f and f inverse on the same axis. So what we have to do here is we just have to sketch the graph of the f. Then we just have to reflect the graph of f on the line y is equivalent to x. Okay, so let's look at to the what is the transformation technique involved here. So we have minus 5 here. So the first one we have to apply the horizontal shifting. So we have plus 5 shows that the graph will shift to the right 5 unit. So we just have to sketch here, shift right 5 units. And then we have 2 here, shows that we need to have horizontally compressed by a factor of 1 over 2. Horizontally compressed by factor 1 over 2. And then we have minus here, so show that we need to have reflect on the y-axis, reflect on the x-axis, so reflect on the x-axis. And the last one, we have shift upward 1 unit. So this is not transformation technique question because we just need to have the final graph to show the f and f inverse, not by using transformation technique. However, we still need to know the transformation technique involved in order to get the correct graph of the f. But we don't have to write down all the transformation technique. Okay, so let's say roughly when we try to sketch the function. So basically the graph of square root of x, so we have something like this with the point of 0, 0. And then we need to shift to the right 5 unit. So we have something like this with the new coordinate 5, 0. And then horizontally compressed by a factor of 1 over 2. Horizontally compressed means that the changes in the x coordinate. So we will have 2 times f by, we need 2 times 5 by 1 over 2. So we will have here 5 over 2 and 0. And then reflect on the x-axis. We should have something like this with the same coordinate 5 over 2, 0. And then we need to shift up 1 unit. Therefore, the final graph should be something like this with the new coordinate 5 over 2 and 1. So this will be your final graph for the function f. So let's sketch properly. So we need to sketch using only one axis, y, and then we have the, let's sketch the line y is equivalent to x. So this is line y is equals to x because we need to reflect the graph on this line later for the f inverse. So this is referred to the line. We need to label all. So for this one, this is referred to the line y is equals to x. And our graph just now, we should have at least one point here. So this is referring to the point 5 over 2, 1. And we have something like this. So the coordinate here is equals to 5 over 2, 1. And this is the graph of the f. The function 1 minus square root of 2x minus 5. So it's not necessary for you to write down the function, but it's okay if you just write down as fx. So whatever it is, so the most important thing is we need to label so that we know which one is the f, which one is the function of f inverse. And then the properties of the relationship between the f, the graph of the function f and the graph of the f inverse. This graph will reflect on this line y is equals to x. Therefore, the graph of the f inverse, so we will have something like this with the new coordinate, with the coordinate of this one we have 5 over 2, 1. So this one, the coordinate should be 1, 5 over 2. So this is 1, 5 over 2. Therefore, the graph will move up here. So this is referring to the function of f inverse x, which is the function is 1 minus x squared plus 5 over 2. So this one must be symmetry. So this is the reflection. We have this shape on the graph of f and reflected on the line y is equivalent to x. So we will have something like this. Okay, so this is the graph of the f and f inverse on the same axis for the part B. And then part C, we need to find out domain and range for the inverse. So by looking at to this function, we can just, since the question just asks to find out domain and range for the inverse function, so we just focus on this graph. So the coordinate of x start from the values of negative infinity until the last coordinate of x is 1. Therefore, the domain of the f inverse is equals to negative infinity until 1 close bracket. And then for the range, so the first values of y, we have to look at from bottom to the top. So the first values of y start from the y is equivalent to 5 over 2. So the values of the y here is 5 over 2. The values of the x here is 5 over 2. Therefore, the range of the f inverse is equals to close bracket 5 over 2 until infinity. So this is the domain and also the range for the f inverse. So let's say if the question asks you to find out domain and range for the f as well. So you just have to change this one. So therefore the domain of the f is equivalent to the range of the f inverse. So it is 5/2 until infinity, and the range of the f is equivalent to the domain of the f inverse. Therefore it is negative infinity until 1. So just in case if the question asks you to find out both, so it must be opposite to whatever we have on the f inverse. Okay, so that is for the solution for the exercise 1.